Assalamualaikum and salam sejahtera to the panel, Professor Amir Ranzi bin Abdul Ghani and Madam Fauzia binti Muhammad Yusof. Right now, I am presenting the presentation of the final year project proposal MEC601. The title of my project is the prediction of the rail pad dynamic stiffness using finite element method. My name is Muhammad Azrim bin Ibrahim. My supervisor is Dr. Abdul Malik bin Abdul Wahab. My co-supervisor is Jupiter Harangan Prasada Manurung. So this is the content of my project. It consists of the summary of the project, introduction, literature review, problem statement and objective, scope and limitation, methodology, and lastly, the expected results. Next, the summary of the project. The fastening system has a crucial role in the railway system as it provides support to the rail track. Rail pads are commonly used between the rails and the sleeper that provide flexibility to the track and dampen the transmission of voice and vibration to minimize these consequences. The service conditions such as temperature, frequency, and toll load affect the nonlinear dissipative characteristic of this material. Many previous studies related only to the experimental and theoretical solution, which are difficult to perform and require a use of special equipment. Therefore, the purpose of this study is to investigate the rail pad dynamic stiffness using the finite element method. The finite element method is a well-known technology in scientific computing that is used mostly to solve engineering problems. The expected result is to create the fastening system model, obtain the dynamic stiffness, and lastly, identifying the deformation of the rail pad itself. Next, the introduction. The use of elastic rail pads can effectively reduce wheel or rail interaction, slow down ballast pulverization, and reduce railway maintenance costs. The dynamic stiffness is important in order to identify the performance of the rail pad as well as describing the elastic and viscous properties. The alternative in order to identify the dynamic stiffness of the rail pads is by using the finite element method FEM analysis. Next, we move on to literature review. There are several studies or research related to this project, which is the dynamic stiffness of the rail pad using finite element method. The first point is the rail pad stiffness. According to Shan Aza in 2020, the study discovered that the variables such as temperature, frequency, axial load, and toll load have the important influence on the stiffness of rail pads. According to Ware in 2018, the results indicates that the storage stiffness and loss factor of Vosloo 300 rail pads increase with the decrease in dynamics load or the increase in preloads within 0.1 until 10,000 Hz at 20 degrees Celsius, and basically linearly increase with frequency in logarithmic coordinate system. The second point is the rail fastening system. According to Sadeghi in 2020, this study discovered that this difference between the results from the linear and nonlinear model of the rail web fastening system as well as the rail foot fastening system. Next point is the finite element method. According to Chen in 2014, the validate of finite element model is used to analyze the sleeper and fastening system under the different loading scenarios involve various vertical and lateral load combination. Both component stress and system deflection of the model are analyzed to investigate the system performance of the component and the system levels. According to Wen-Shu Lee in 2015, the rail support can significantly affect rail dispersion and frequency response below 1 kHz using semi-analytical finite element method. Now we move on to the problem statement and objective. The problem statement, most of the study that being performed in order to identify the dynamic stiffness of the railway fastening system are conducted by experiment and analytical method. This study do not indicate the overall view of the rail pad's behavior and difficult to perform because the experimental require the use of special equipment. Thus, finite element method is needed to see the overall view of the specimen, easy to model complex geometry and irregular shape, and also accurate in solving the problem. The objective of this study is to develop a simplified fastening system model under operation. Second, to investigate dynamic stiffness characteristic of the rail pads under the different parameters changing. Next, we move on to the scope and limitation of this project. There have been numerous previous studies on the dynamic stiffness, particularly when using finite element method in order to solve the problem. This study involved vibration, the strength of material, and also the simulation method. There are also limitations of this research, such as only conducted in the computer software and using finite element method and software model. Next is the methodology. As you can see, there are the flow charts which represent the overall methodology of this project. The first one is the literature review about the fastening system. In this section, we gather the information about the previous study and provide us some fundamental understanding before begins with the finite element method. The second process is the modeling process of the rail pad. The modeling takes place in the computer software, which is the Alte Hypermesh software. Next is the validation of the model by experimental measurement. The validation, if the validation is acceptable, we can proceed with the second objective, which is the prediction of the dynamic stiffness of the rail pad. And lastly, the objective is the parametric study, which involve mechanical properties, geometry, loading, and temperature. And last but not least, we write a report of our finding. Next, the table shows the material properties of the railway component. This table can be obtained in the previous study. It consists of the Young modulus, portion ratio, yield strength, ultimate peak strength, and cracking strength that involve concrete, rail pad, and rail. Below is the flowchart of the finite element method analysis. The first one, the process is the geometry, which is the model. Second is the material that we applied to the model. Third process is the meshing. The fourth process is the boundary condition, which we applied force and fixed position. And lastly, the solution, which consists of two, that is the hyperplastic elastomer and meshing size, in order for us to get a better result. Lastly, we have the equation of the dynamic stiffness. The K represents the dynamic stiffness, the F represents the average force, maximum and minimum, and the D stands for the deformation, average deformation, maximum, minimum. The deformation can be obtained from the simulation itself. Next, we move on to the expected result of this project. The expected result of this research can be summarized as follows: identifying the model, recreating a model of the rail fastening system through validation, identifying or determining the dynamic stiffness of the rail pads by using simulation, to determine the effect of parameters towards the dynamic stiffness of the rail pad model. That's all for me. Thank you.